All right. Hello, everybody, and welcome to day 4 of the 2022 Charged Up Preseason Panels. Today we have a double panel, which means we'll be having 2. So starting us off with the first panel of the day is going to be Serena from Team Spider, who will be giving a presentation on the Impact Award, formerly known as the Chairman's Award, for those of you who have worked on it in the past. As always, if you have any questions, you can put them in the chat, and they will hopefully be answered at the end. And with that, you can share your screen. Take it away from there.
All right. Thank you so much, Zoe. Yep. My name is Serena Feluccio. I can't share my screen without muting myself. Is that going to be a problem?
Yeah, technical difficulty.
So, all right. So sorry about that. We had some technical difficulties, but yes, as Zoe said, my name is Serena Feluccio. I have been on Team Spider for about a year, and I'm going to be talking about the Chairman's/Impact Award. So, who is Team Spider? Previous people who've probably been on like the previous Zoom meetings or live streams probably already know this answer, but I'm going to be talking about it. Team Spider is going on our 18th year. Team Spider is a robotics team that represents Poway High and the Engineering Academy, which is basically a pathway for students to take to help them get their ready for being an engineer in college, or we build and program robots to compete in competitions like FRC and, well, we used to do VFX, but now we're doing FTC. But we're so much more than that. For example, we have a business team, a PR team. We go to local government meetings, and I'll talk more about that later. So what is the Impact or Chairman's Award? It's the most prestigious award at FIRST, and it is given to the team that represents the FIRST role model and best embodies the mission of FIRST. So on my screen, you can read the mission of FIRST, but basically it's encouraging others to go into like STEM-related jobs and just get them excited for STEM. It also helps students learn skills like self-confidence, communication, and leadership. Right now, I'm actually in a leadership position, and I can say that this has really pushed me to be a better leader and learned how to be a leader. So what does it mean to be a role model? Well, it means that your team is sustainable, which means that members who, like, for example, seniors pass down their knowledge to the less advanced students so that they can learn, and so on and so forth, so that everyone, like next generations, know what they're going to do. And next, good sportsmanship. So basically, if you lose, then you're not like, oh, well, frick, I hate everyone. You're like, well, that was a good match. Being respectful to others, whether on the team or not, kind of plays into the good sportsmanship. But for example, what I'm doing right now, I am helping another team with their series, and I'm being, we're respectful to each other, and we're not like, I hate you because you're on another team. Mentorship of other teams and new members on your team. So like I said, with sustainability, you're basically mentoring new members on your team and mentoring other teams. What Team Spider does, I don't know if you guys do it, but we like to go out and find local teams around Poway especially, and we basically help them get through their season. For example, I'm mentoring a FLO team, which is called, I believe, the Three-Headed Horseman. And I typically go on Zoom meetings with them and I talk about like, oh, you guys can improve this. Oh, you guys can improve that. I also help them when they're working on their robot. So that's what it means to be a role model. So these next few slides, I'm going to talk about who plays into the chairmans and how chairmans on our team is made. For example, the business team, we're responsible for basically everything that has to do with imagery, safety, and documenting. Business is more than just writing and documenting. It has a lot of smaller sub-teams. Like I said, imagery sub-team, safety sub-team. She's secretary and executive assistant. So going into that, public relations or PR team, the PR sub-teams work on outreach events promoting the teams, promoting the Team Spider and the FIRST program. They oversee the organization and documentation for events and programs the team hosts and runs. For example, this could be considered a public relations or assignment, or and outreaches are basically like going out into the community and spreading FIRST, or sometimes even helping clean up, which I'll talk more about that later. But who is in PR and who are the leaderships? Historian, which is basically our photographers. Marketing media lead, basically the ones who put stuff on media and stuff. And then local and global outreach coordinators, which currently are our two co-presidents. But that would be in the public relations area. Oh, here. Outreach events. The team we host, run, and organize multiple outreach events globally, locally, and virtually, as this one. And this includes like showcases and run competitions. We've gone to Ecuador, Benin, Paraguay, and Mexico. I think we've also gone to Togo. Locally, we have done informational nights, e-waste events, which are basically people come to drop off their like computers and on like electronics, and we dispose of them safely. We do summer camps, which I believe before the pandemic, we used to do in-person summer camps where people would come and we'll have different activities, such as I remember they used to do keychains where you could CAD or make your little keychain of your name on the computer. And then we would go over to the shop or the place where all like the robot is made and everything. And we would 3D print them, which was really cool. Clean Web Initiative. This is what I was talking about earlier. This is where we go out and we clean our beaches and we clean our parks and stuff like that. We've had a lot of those because we want to keep Poway clean and we want to make sure that everyone is just having a good time at those public areas without having to see any like waste or stuff like that. Robot demos. Basically, we go to different like sometimes we go to museums, we go to libraries and stuff, and we bring our robot and we talk about what it means to be in robotics and how it has impacted us. And then we go around and we start like running our robot, and our robot that we check out, it shoots little like tennis ball, well, not little, big tennis balls, and the kids love it. We also do scrimmages, which is basically an FLL. A scrimmage is like the prior competition. It's just like a little competition that doesn't really count, but it gives people feedback. I have actually judged that one of those, and we have done those recently. That was really fun. It's really cool to see the younger generation come and actually be excited about STEM and robotics. And then virtually, we've had our fourth annual STEM series or career series. I actually also hosted that, and that was really fun. We got like different speakers from around California and some in like other parts of the country, and they would come on virtually, and from 5 to 6 they would talk about their experiences in engineering and other parts of STEM, and they would walk us through like their position. For example, I believe there was a railroad engineer who explained that why roads look the way that they do, and how weather and cars and all these different aspects affect how they make roads. So moving on. Political advocacy. This is something that us at Team Spider do, which basically we go out and we meet with our city council, our school board, and politicians around the world to help spread STEM. This is everyone on the team is welcome to do it, but I know that mostly business does it. For example, we write the moving on. We started the Robotics Day in Poway Unified School District in 2014. We also started it in the city of Poway in 2018. And the San Diego, recently we have petitioned for it to be in the San Diego County. And we've also petitioned for a Women in Engineering Day, which has gone through, and we will be celebrating that. We've also engaged the school board. For example, we've talked to the mayor of Poway, Senator Joel Anderson, State Senator Brian Jones, Assembly Member Brian Manshine, and the Governor of California to promote STEM. We've also advocated for more STEM funding at Washington, D.C. with SASA, or Student Associations for STEM Advocacy. I went to that, and it was such a great experience to go fly up to Washington and meet with a bunch of other teams, where we walked around and talked to different senators and representatives. For example, we met with the Representative Sarah Jacobs, Senator Alex Padilla, Representative Daryl Issa, Representative Mike Levin, and Senator Dianne Feinstein, office staff. All of them were really nice, and they all were like, yes, we have to get more funding into STEM because it's a really important thing that we do. It was really great, especially since one of our coach's daughters lived in Washington, D.C., so we got to see her, and it was a great time. So during the season, or during build season, what does the business team do? To prepare for the competitions, we work on the essay, which the essay is basically, for the Chairman's Award, you have to make an essay, a speech. Well, we do a speech, an essay, and a video. The essay is basically talking about like what we do on the team, what the robot team does. It's basically a summary of what we've done throughout the year to prepare. That's also the video. It also explains that. We do a presentation or speech where we all, on the day that we present on the competition, we all dress in suits, black suits, and you go into a different room. You don't have to dress in suits. We just personally do that. But you go into a separate room, and you have like 2 or 3 judges, I believe, who you speak to about what your team has done, basically what the essay is. And yeah, we also bring with us booklets in a binder, or this year we're going to do a magazine, which basically also is like evidence of what we've done. One pagers are relative to outreaches. It's basically evidence that we've done outreaches. And we put that in the binder or magazine. The imagery team, typically they work on drive team uniforms, team t-shirts. So what you see on my shirt right now, that is the imagery team. And they typically take this logo and they put it on the team buttons. So if you ever go to the competitions and you see us, you'll see that like we'll have big buttons with this logo or another logo. They also work on, like I said, drive team uniforms, which basically are like suits that the drive team wears to represent Spider. Flyers, that's typically when we're doing like an event or an outreach, you'll see those. I know that if you go to our Instagram, a lot of the Instagram posts are made by imagery. So I've actually helped them with that, and it's really fun to learn how to make posts on Instagram and basically how to make flyers. We also made the team mascot costume, which is, well, if you've seen us, we used to walk around in a fire hydrant suit that said think safety. Sadly, it has been damaged, so we will no longer be doing that, but we have another mascot costume, which is basically like a robot spider. I think it's really cool. Also, one thing that's not on here is we have ordered a bunch of like stuffed spiders that we will be hiding around on the competition, and each member of the spider and even some of the mentors and coaches get some, so look out for that. Safety. I haven't really talked about safety, but safety is a big part of Team Spider because our motto says think safety. So safety typically works on a booklet, which basically states, what we've done, kind of like the business booklet, but it also has like, I believe like rules to follow and stuff like that. We have been working on safety training, but we also do that during build season. And basically safety training means getting the whole team and we talk about what is safe to do, like don't burn your hand, or don't poke yourself with sharp objects. But to further ensure this, at the beginning of our season, we typically make sure that everyone has a first aid, and make sure everyone's first aid, AED, and CPR certified. That's so that if any of the coaches aren't there to help another student, we can easily help them, and we have that knowledge. So competition season. During competition season, the business team prepares for their impact award presentation, while also talking to judges that come up to our pit. So like I said earlier, we make a presentation that we're going to talk to judges about, but judges don't only see you when you're in a room with about like 3 people. They also walk around during the competition. So when we're talking to judges, we always have at least one or more members of the business team at the pit in case any judges or students come up and ask questions. We also have a banner with all of our information that we make before competitions. This year, we're going to have 2 banners, and the banners basically have state this is what we've done. These are the locations that we've been to and mentored. It's the imagery and the business team both work on that. And like I said, we have at least 2 or more or 1 or more people at the pit just in case judges show up, which judges will typically come to your pit, ask questions, and about whether it's the robot, whether it's the business, or anything really. But we make sure to have those just in case. For the impact presentation, each team member prepares a presentation about what their team has done throughout the year. So that's basically what the impact presentation is. I have done it before, and both of the judges have been really nice, and it's been it's a good experience because you get out of your shell, you start talking to people more. Yeah, that's all I have. So we can open it up to questions.
All right. So I do see some questions in the chat. First question is, how did you develop your international outreach, showcases, and competitions, and what do you do at those events?
I'm a bit confused on the question, but I'll answer it as best as I can. Basically, different team members reach out to like different teams in different countries. For example, in Paraguay or Libya, our coach actually is really good friends with another coach in Libya who basically oversees all the FLO or FTC teams. And we create connections like that, and we continuously build on those connections. So over the years, we have just had a strong connection where when they need help, we go over and we help them. Hopefully that answers your question.
All right, thank you. Next question is, what types of questions do judges usually ask in a chairman's presentation?
When I was doing the chairman's presentation, they asked us how FIRST has impacted us, how being on the robotics team impacted us, and what we got from being on the robotics team. Personally, being on the business team, I have learned how to be a leader. 2, I have experienced business, a level of like a business environment. So that has prepared me for the workforce. And basically, yeah.
All right, another question is, what's your favorite outreach that you've been a part of?
Recently we have done qualifying tournaments, and it's really fun. I have been volunteering at the snack shack at those places, and it's just really chill. A lot of the new team members are really cute, and they're really just like excited, and it's really just like fun to see them like what if their robot doesn't go well, they're like, okay, what did we do? And they talk to each other about it. And it's just a really fun experience. But also another outreach that I've done is we have painted like these little candle holders for, I believe, a Hindu church. That was really fun, and I learned a lot about the religion.
All right, awesome. Another question is there any crossover between your business and build/tech teams, or are they separate?
Imagery, well, yes, we cross paths. For example, imagery typically helps work on the panels of the robot. For example, if you look at any of the FRC robots, you'll see that they have like the team name and like designs. And sometimes, well, we put our sponsors on there, and so they have worked together to make that. Business, we kind of have to learn about what happens on the mechanical team and like the robot team, so that we can put that in the binder in our presentation. So there is, well, some at least crossover, but those are the ones that I can mostly think of.
Okay, thank you. Another question is, what has proved to be your most successful outreach event?
That's hard to say because we've had so many, but I would say the STEM series, because a lot of people were interested in it and a lot of people learned from it. I remember just taking away from one of the presentations not only about learning about engineering and his field, but also he said it does not matter what college you go to as long as you have a good enough degree and you learn a lot, which has impacted me a lot because that just furthers like, oh, I don't have to go to Harvard. I don't have to go to like Yale to get a good job. Just knowing this, like your jobs won't be like, oh, you didn't go to Harvard. Sorry, you can't go here. We don't accept you. They're like, okay, you have this degree, you have this degree, you have some knowledge of what we want. You're on the team, most likely.
All right, another question. How do you develop business connections? Is it cold call or referral?
I need you to like build on that because I'm a bit confused. Like, what do you mean by business connections?
I think they're just referring to like how do you build like connections to like corporations for like mainly funding, I think, and things like that, and like access to resources. Because I think that's a lot of what teams will struggle with, especially ones that are just starting out.
Yeah, typically we have like parents mentor team, or yeah, mostly parents, and they have connections outside, but also if you just like basically explain to these like reach out to these companies, they're more than willing to talk to you about it, especially like engineering or STEM related businesses. For example, we have been paired with Northrop Grumman for a long time, and I know that they've also sponsored a lot of other teams. So mostly we go through parents, but also if you ask them and like talk to them about it, I'm sure they're willing to uh, partner with you guys.
All right, another question. How do you think business and outreach has changed your robotics experience?
Well, I haven't really been doing much of the robot part, and even uh, when I was like a rookie on the team, I didn't even know about like business. I didn't even know about PR. I didn't know about these other. I was like, it's just programming, electrical, and mechanical. That's it. But once I found out about it, I was really interested, and it piqued my interest in that field. Um, like writing and stuff, but also I've learned to write better essays. I've learned to speak. I've learned, for example, what I'm doing right now. I've also learned how to be more organized because in order to make sure like what outreaches we're doing and everything is like going smoothly, you have to learn how to be organized. Um, so that's basically how it's affected me. I'm sure that if you ask others who have done it, for example, I believe Zoe, you've been on the PR team, right? Or you are. She could probably tell you like her experiences and how it's impacted her.
All right. I think I saw another question. Oh, can you provide a little more detail of what your business sub teams do, like safety, business, etc.?
So going into the nitty gritty, we take the almost the entire build season to write out an essay in like categories of like this categories of like what we've done. For example, we for like one could be like advocacy, and we basically talk about, oh, this is what we've done. We've gone to this place to help support STEM and stuff like that. We also like prepare, and we like help train people on public speaking for the speech so that they are ready to go and stuff like that. Um, we've also let's see, I'm trying to think, blanking out right here, but I've we also work on like questions that we have to fill out for the chairman's award. Those typically go out around, I believe, January-ish, like January 7th, and 2 days before my birthday. Um, and safety specifically, they go around and they check to make sure everything's going well, that everything's safe. We want to do a safety animations video, which you can actually win an award for. And we, in the past, you could have won you get like a little star, which is really cool. You can also win like safety star of the day, which one of our team members have won, and they got like a big giant bag of candy. Um, in imagery, they do like the Instagram posts that you see throughout the year. They work on t-shirts and buttons and stuff like that, and sometimes they help like decorate the robot with the panels and stuff like I mentioned, but that's basically it.
All right, cool. Next question. If you haven't mentioned it, how large is Spider's PR/business team?
It depends on how many people want to join business and PR and stuff like that, and how many people are on the team anyways. Right now we have like pretty small number, because when you join robotics, you're not like, dang, I want to start writing papers right now. You're more of, I want to build a robot, I want to like do all this other stuff. So not many people join business, but throughout the like build season, they typically start like trickling in and stuff. Like they're like, oh, that actually seems cool. But right now there's like about 3 people on the business sub team, about like 7 or 10 people on imagery, and PR and business basically smushed together. So it's kind of like 4. So yeah, that's basically, it's really small numbers.
All right. Next question. Do you have any advice from small teams trying to expand their outreach when so much time is already spent on the build just to compete?
What we typically do is we ask our members to complete at least 1 outreach and go to at least like 2 outreaches. Outreaches are typically done outside, like our first trimester. Before build season, we typically do a lot of outreaches, and it doesn't have to be like worldwide or anything. It can be just going to your local park and helping clean up, or going out to your local schools and make like informational nights about what you guys are and stuff like that. So my suggestion for small teams is to just go locally and set up outreaches that are mostly outside of school and outside of like build season.
All right. Another question. Wait, hold on. I already answered that one. All right. I think that's all the questions we have for right now. Thank you so much, Serena. That was an amazing presentation. No problem. All right. With that, I think we're going to head on to a break. We will be back at 12, or not 12, 5:50 for our second panel of the day with Kodo. So, yeah, you can go on break, but don't head too far because we still have one more panel.
All right. Thank you so much.
No problem. All right, hello everyone. We are back from break. The final panel of the day will be presented by Kodo about how to have a successful kickoff. So like last time, if you have any questions that you want answered about anything in the presentation, please just put them in chat and we will answer them at the end. So with that, you can take it away, share your screen.
Hi, thank you all so much. Does everything look okay? All right, I'm gonna assume so. So this presentation is about running a successful kickoff, and we can just get into it. So my name is Saikran Ramanan. I've been a mentor on Team 3476 Code Orange since 2015, and I'm currently also a mentor on Team 581 in San Jose. This is going to be my 13th season in FIRST. I am a digital engineer at Google, so I work on hardware and chips like that. But I really love doing strategy and high-level design and programming in FRC. And I also love coffee and clean wiring. So that's a little bit about me, and we'll get right into it. So before we get into all the details, what is kickoff? I think most of you all know, but just in case there are any new students out there, it is the first weekend of season where teams get the new game. A well-run kickoff provides a good basis for a successful season, right? So it is the weekend where you get your game manual, it's where you get your video, it's where you get your field drawings, and you want to figure out what you want your robot to be able to do that weekend. You need to figure out what you need to learn, and you need to figure out how you're going to start trying to design those features, as well as make a schedule for the rest of the season to conform to. So before, we went to kind of like an overview of kickoff, there are some rules that we need to kind of go over that should dictate the season itself. And there are things that we're going to come back to often. So one of the golden rules is keep it simple. Simple robots break less and you can get more to go your way, right? It's all about creating your own success at the competition and creating your own luck. So making a simple robot that you can maintain and design well and get all the features out of is going to be way better than a complex robot that breaks all the time and you can't really see all the features through, right? So keep it simple. Another thing is fail fast. One of the best teachers is failure. So failure isn't always a bad thing as long as you learn from it. So it's super important that you learn to fail fast and iterate from your failures so you can try to maximize the potential of anything that you do. Another thing is that schedule should dictate decisions. You should figure out what you have the time for, and you should use that to try to, design your robot around. And if your schedule slips, you need to readjust your priorities and figure out how to make sure that you can hit your schedule so you're on time. Because you can make the craziest and coolest robot you want, but if it doesn't meet the competition deadlines or your deadlines for practice and all that, it doesn't matter. And you want to leave a lot of time for practice, and we can get into that a little bit too. And finally, don't reinvent the wheel. FRC, a lot of the problems that you see here are a solved problem, right? That there are a lot of parts from previous games that you can use as inspiration for your new robot. Most things aren't new in FRC. But if for the things that are new, right, you can learn from a lot of different sources, and we'll also get into that a little bit. And with that, we can get started right into season. Oh, sorry, there is a couple more things. Another thing is in preseason, right? You want to go into season with your entire team gathering together and figure out how to define your team success in the year. And these are things that can be internal as well as competition goals, right? Do you want your full robot cat to be done? Do you want clean electronics? Do you want a lot of new students working on design? These are all things that you need to figure out and take with you as measurements of success. You also have competition goals, right? Do you want to be picked at an event? Do you want to play in eliminations? Do you want to win a regional? Do you want to win champs? No matter what the goals are, you want to make sure the entire team has buy-in and agrees that these are the goals that you want your team to strive towards. And with that, right, you can use that as a framework to make sure that the decisions that are happening in kickoff align with your goals. And it's a good way to unify the team and come around, a central set of goals. All right, so right here, it's the 10-step design process. This is the process that a lot of teams in FIRST uses. This is the 10-step design process that Code Orange uses to approach every season. It's a good way to organize your thoughts, as well as make sure that you're not doing things totally willy-nilly, if that makes sense. Iteration is very key at every step of this 10-step design process, even though it's a list, right? You want to make sure you go back when you learn new things and augment your everything that you've kind of achieved and done at every step to make sure that you're not carrying old thoughts forward, right? Build season is an intense time where you learn a lot really quickly. So you want to make sure that you carry your new learnings forward. And we're going to be talking about steps 1 to 6 today, unless we have a lot more time, and then I can get into steps 7 to 10. But step 1 is to define the problem. Step 2 is to generate specifications that your robot might need to do to solve the problem. Step 3 is ranking those specifications to figure out what you want your robot to do to meet your goals. Step 4 is finally brainstorming design concepts. Step 5 is gathering data on those concepts. And step 6 is choosing a concept based off of your specification ranking, your design concepts, and the data you've gathered. And all 6 of those steps can basically happen during kickoff weekend or the first week of season. All right, step 1, it's define the problem. You want to get your entire team together on kickoff morning, right? I think the time differs all across the US, obviously, because everyone gets it at the same time. Out here in California, it's pretty early in the morning. And you want to get your entire team together. And as soon as the game manual drops, you want your entire team to read the manual. For small teams, it might look like you gather everyone in your group together in one room, and you just go through the entire manual line by line out loud and popcorn it to different students. For larger teams, that might not be effective and it might not captivate the interest of students a lot. So what you might need to do is break up your group into smaller subgroups and have each of those subgroups study different sections and have each of those subgroups come up with a small presentation for each of their sections. So everyone on the team eventually at the end of the first day understands everything in the game manual. And I keep on saying whole game manual. It's really important because robot construction rules change year to year. It's important that everyone is on the same page about how you score, about how, legal ways of doing things. So it's super important that everyone understands basically everything on the first day. All right, so after you've read the entire manual, you want to ask yourself 2 questions, right? Question number 1 is, how can we be valuable alliance partners? And question number 2 is, how do we make a competition legal robot? So when it comes to question number 1 for how to be a valuable alliance partner, you want to list out all the ways that your teams can score ranking points, right? So those are the points that you get for either winning a match or performing a game-related activity, right? So in 2022, that was scoring 20 cargo in any of the goals, as well as getting 15 climbing points. So those things change year to year, right? So it's important that you figure out all the ways you can get ranking points. It's also super important that you figure out all the ways that you can score. And it's also very important to figure out all the ways that you can prevent another alliance from scoring. In addition to that, there are safe zones that you need to recognize and list out, as well as figure out anything else that dictates how you can win matches or seed high. So those are the different ways that you can be a valuable alliance partner. The second thing that you need to list out is how to make a competition legal robot. So that includes your starting perimeter, right? Like how big can we make a robot? How tall can it be? How tall and wide can we actually extend out as soon as the match begins? You need to check what motors might be legal, if there are any limits on motors. That hasn't happened in, I think, almost a decade. So I don't know if that's really worrying out, but it's always a good thing to make sure of. And you just want to make sure that everything that you try to think of this weekend falls within the legal robot framework, or else your concepts and ideas won't work and they're just kind of useless. So it's super important that you understand what a legal robot is in step 1. So once you have the list of the different ways you can be a valuable alliance partner and the different ways to make a competition legal robot, we'll move on to step 2. But actually, kind of going back to how to be a valuable alliance partner, this is something that is really cool when people talk about. So there are a thing called chokehold strategies. It's a way to kind of break the game by finding an exploit in the game rules. And 469 in 2010 was one of the teams who was able to figure out a chokehold strategy, something that no one else in the world basically was able to find. Those group of students and mentors got together and came up with this idea, and they were better than basically everyone in the world. So this is a really great example of it. So you can see that this game is kind of like soccer. And they have a ramp that just redirect balls from one side to another, so no one could defend them. There's only one defender allowed on that side, so if the defender was on the right, they could just direct the balls left, and if the robot was on the left, they could just redirect the balls right. And this robot could just sit there and do this all day and could score a lot of points. So modern games don't really feature chokehold strategies anymore. The game design committee is pretty good at trying to find those exploits early and often, and squash it before teams get a hold of them. But it's something that is super important for the entire team to look at when going through the rules the first time. All right, step 2 is generate specifications. This step is meant to organize thoughts on the potential game and generate requirements that your robot may or may not do, right? So in here, you want to basically list out everything that your robot could do in a game, right? Whether you think your robot should or not. So I would split this up into 3 different fields, right? So one is field actions, another one is game piece actions, and the final one is construction actions. So for field actions, right, it's how your robot interacts with the field. So you could have drive fast be one or drive slow be another. For the 2022 game, right, I would say a field action would be climb to low, climb to high, climb to mid, climb to traversal. Those would be 4 different actions. We had in 2022, we had a cable protector in the middle of the field. So being able to drive over that is an important field action to consider. In 2020, if any of y'all remember, there was a bunch of metal pieces in the middle of the field that protected the climb zone. And it was important that robots could drive over that or think about driving over it. So I would list out everything relating to the field there. There are then game piece actions. So game piece actions are different ways your robot can interact with the game piece. So one example is pick up a ball from the line station, or pick up the ball from the ground, or score the ball high, score the ball high from the protected zone by the truss, score the ball high from far all the way against the lines wall, right? I would list out all the different places you can score from, all the different places you can score. Another cool one in 2022 is there are certain teams that figured out, hey, a potential action a robot could do is eject the wrong color ball, or I can pick up the wrong color ball and shoot it all the way across the field, right? That's a valid game piece action. Teams like 254 and 1678 and 1323 were able to identify this early and write it as something they wanted their robot to do. So I would list out literally everything that you can think of. It's a great way to also get new students involved, because you can kind of throw softballs at them if you're trying to get them more comfortable with speaking in large groups. But this is a really great strategy muscle for everyone on the team to flex. And finally, you have construction actions. So those are things like, we want clean electronics, or we want, a lot of space for electronics, or we want to make sure our breaker is placed in such a way that it can never be accidentally tripped, or I want the robot to, or the robot can be a small frame perimeter, things like that. So list that out as well. For Code Orange, these lists are probably like in each of these 3 categories, maybe 30 long for each one. So you can get pretty intensive and specific about this. Moving on to step 3, it's specification ranking. So once you have this full-on list of all the different things your robot could do in the game, you want to try to rank what your robot should do in a game. And the way that we approach this framework is by labeling every specification with a wish, a prefer, and a demand. So a demand is a requirement that we need to be able to do for our robot and our team to meet our goals that we laid out before the 10-step design process, right? So we're now bringing in the goals that we talked about earlier. So, for example, if your demand, or if your goal is to, play in eliminations, right? I think a good demand would be to climb low or to climb mid. I think that's a really good demand. I think a good demand is also to, drive across the entire field, right? Be able to, go over the cable protectors. So demands are things that you need to be able to do to meet your goals. Then you come to prefer. So prefer are specifications that would be nice to be able to fulfill your goals, but aren't strictly needed, right? So if your goal is to, let's say again, to get selected and play in eliminations, right? I think it is a preferred that your robot is able to score balls in the high goal, right? I think that's a prefer. You don't really need that to be picked, right? Because you can, or to play in eliminations, you can be an alliance captain, you can be a first pick, you can be a second pick, and second picks are, at the regional level in California are generally like climb robots or defense robots, right? So it's not strictly needed. So scoring low would be preferred for that goal. And finally, there are things that are wishes. So wishes are things that aren't necessary at all to reach your goals. They might be harmful for reaching your goals as well, right? But they're things that you're not going to, model the rest of your season after, right? So as a group, I would go through every single step and say like, hey, this specification is a demand or prefer or wish. And I don't know if we talk about this later, but I think it's very important that teams don't vote on these things, right? It's good to build consensus as a group. And what I mean by that, right, is voting inherently is a process that is very divisive. You end up getting sides that are like, hey, no, this group of students think that this is the right way, or this group of students think that this is the right thing. And it becomes about getting the majority, right? Not about finding the right solution. So in engineering, we like to build consensus. So that is making sure that everyone is heard, making sure that even if there is one voice that doesn't agree with the decision, you go back and you try to figure it out and either convince them or they convince you. So everyone feels heard and you come to the optimal decision and, idea, right? So I would build consensus and not vote when you're doing the specification ranking. And it's also really important to keep in mind here your resources and your schedule, right? The schedule should drive decisions. It is better to be really good at one thing than to be like mediocre at three things. Being really good at one thing means that you can make it work every time, that it'll always, no matter what, it's going to happen, that teams can rely on you to make it happen, compared to like a robot that can maybe do it on a good day, or can do like three things maybe okay on a day. So that's something that to keep in mind when doing specification ranking. All right, so this is a sample wish preferred demand list from 2022. So this is really small, right? This is a certain selection of specifications from step 2 that we're going to rank here. So let's just say for a low resource team, right? I applied like low, medium, and high resources to teams. I don't actually think that's the right way of categorizing teams, but it's like a super easy shorthand that we can go over really quickly. But like a low resource team, right? If your goal is to get picked at a regional, and if your requirements are these, like it's swerve, turret shooter, shoot from up close, shoot from far, low goal, climb level, right? I think swerve is a wish, right? You don't need a swerve to get picked at a regional. Tank drive is, real good, or the kit apart drive is really good. Turret shooter is also a wish. Shooting up close and shooting from far are both wishes. You don't need, to shoot to be picked for regional. I think local might be a demand, so you can contribute to the RP early on, and so you can score a couple of balls at the end of the game as a tiebreaker. That might be a good thing to reach for with this set of goals. And I think your climb level, right? I think climbing low or climbing mid would be a demand for you, and climbing high and traversal would be a wish. So those are mostly wishes and like 3 demands, right? That seems pretty reasonable for a low resource team to be able to do. Let's just say you get into the range of a medium resource team and your goal is to be an alliance captain at an event. Swerve, I think, is still a wish. I think in California, we saw that most or a lot of alliance captains were tank bots, and tank bots were really good still. Turret shooter is still a wish. Shoot from up close is probably a demand, right? It's super easy to shoot from up close, and it's like a spot that you can drive to reliably, and it's hard for teams to defend you when you go there. So I think shooting from up close is a pretty big demand. Shooting from far is a preferred if you can make it happen, but I don't think it's really necessary. I think that the best example of this is to look at Team 1339. They're from Colorado. They came to the Orange County Regional this year, and they were fantastic, right? They were finalists at Orange County, and they were a non-turret tank drive robot that could only shoot from up close, and they were so good. They also did really well at champs. I think they got to semifinals of their division, or finals. And I think they might have lost to the eventual winners, but it's been a while since I've looked at them. But 1339 is a really good example of, not doing everything and, being able to achieve a lot. They also won the Colorado Regional, I think. Low goal is a wish for a team like this, right? If it can shoot from up close and it's a demand for your robot to shoot from up close, you don't need to score low because, your robot is going to be able to shoot from up close. And finally, I think for climb level, if you can, demand a high climb and have low and mid be, prefers and the high be a wish or prefer, I think that is fine, right? I think that's a good way to make sure you're not overstretching your team. And finally, for like a high resource team, like if you're, like 1323 or 254 or something like that, right? If your goal is to win the world championship. And I think swerve would be a demand at this point. I think turret shooter would be preferred. I don't think turrets are really necessary to compete at any level or at high levels. You actually saw that. And I think I talked about it in a bit, but you don't need a turret to compete at a high level. I think shooting from up close would be preferred, but it's not something that you need to be able to do because, if you're a high resource team whose goal is to win the world championship, right, you should be able to figure out the vision code to be able to auto aim. So shooting from far would be a demand. So you could shoot more, shots that are harder for a defense to intercept. Low goal would be a wish, right? Your robot does not need to do low goal for you to reach your goals here. And I think your demand is a traversal climb. So there are some teams who were their goals were to win the world championship this year, right? Like team 3310 or team 125, who they could climb mid and they could climb traversal. The robot, skip the third level. So high was not a demand for them. The traversal was. So this is kind of like the framework that you can use to start designing these robots in your head at this point in time. So a lot more goes in at each level. This is a really simple example. I would add in every single thing that you talk about in the specification thing. So it might end up being 30 to 60 things. So go through every single one of these and talk about, given your team's goals and resources, what do you think your robot should do to reach your goals? And this is actually where I kind of talk about it. This is a note about complexity and ambitious goals. A lot of teams think that to have ambitious goals and to meet them, you need to have complex robots. And that is definitely not the case. So in 2022, Einstein is the finals of worlds, right? So this is at the world championship. The winner of the 6 divisions play against each other. So 5 out of the 6 alliance captains on Einstein this year were robots without a turret. I think all of them had swerve drives. And were really, really, really good, but none of them had a turret, right? They all chose robots who might have had turrets or might not have. I don't think that's the kind of point here, but they were able to compete at the highest level without going as complex as a turret. Another really great example is this team that I have a picture of, and that's Team 6328 from Littleton, Massachusetts. They were one of the top robots in Einstein. They were chosen by Bread, and they were the first pick by Bread, and they were a robot that had pink drive and no turret. They were just really fantastic, and it was a robot that a lot of teams could really build. So I think they're a really good example that even if you have super ambitious goals, you don't need a complex robot. And additionally, right, most teams never hit the competitive ceiling of their robot. Like a lot of teams build super complex things that they can't really optimize correctly because they don't have enough drive practice or enough programming practice, right? So keeping it super simple, keeping it something that you can try to get to the ceiling of is way more important than making something that has all the features. All right, so now that we've gotten steps 1 to 3 out of the way, right? So we have specifications that we know that we need a robot to be able to do, right? Those are demands. And there are things that we kind of want a robot to maybe be able to do. Those are prefers. It's time to brainstorm design concepts. So this is the how for all the requirements, right? So before you were just talking about the requirements and not how you're going to actually satisfy them. But this is where you get all your students out and have every single student, draw a different robot concept and draw different ways that they can design a robot that will be able to have all the features of your demands and some of the features of your prefers. And here, right, I would say this is where steal from the best and invent the rest come into play. You don't need to reinvent the wheel. I would try to have your team familiarize themselves with robots from the last 5 games, right? You don't need to familiarize yourself with all the robots, but the top 5 to 10 best robots from the last 5 years. And if you do that, right, all your students can be like, okay, it's an elevator game, or it's a lifting game, right? It's a pick and place game. So I saw this robot have an elevator, so I know to draw an elevator. And maybe we want to like pass a game piece through the robot. I saw a team in 2019 do that. We got to climb this thing, right? Like there's a climber that's going to come up and pull on the bar. So it's super important that like you have your students not approaching this with no background, or else people can get lost. But to have some sort of background and try to, put everything together, and for things that you don't have a solution for or that teams haven't done in the past, right, come up with new ideas there. This is actually a really great example. This is our 2020 robot, and this was made on day 1. This was the drawing of the robot that we made on day 1. So you can see our intake, our shooter, our climber. There's even a thing for the camera, which is really funny. The robot ended up basically looking like this. It's essentially this. So it's really cool seeing that we basically had this concept on day 1 itself. All right, so now that you've had a lot of students, put onto paper their different ideas, it's important now in step 5 to gather data on all the concepts. So this is, taking a look at all the different designs and seeing like, okay, this is really cool here, right? Do we know if it'll work? And there are a lot of different ways of doing that. So it's really important for you all to know that there is chiefdelphi.com. It's an FRC forum that is super active and people post on all the time. So you'll see reveal videos there, you'll see prototype videos there, you'll see open line stuff there, you'll see everything there. So if you can have a couple of people monitor that, that'd be really good. They're Robot in 3 days. So those are groups of, folk usually in college who get together on the first 3 days of season and make a really quick robot. Those robots generally aren't the best to follow, but they often showcase examples of mechanisms that are fantastic for teams to use. So it's a really good resource to have in your belt or in your backpack to kind of reference when you have an idea, saying like, oh, okay, I can look at this Robot in 3 days team and like, oh, they did something similar, or oh yeah, it didn't work here, or it did work here. Another good example is Everybot. We'll get into that deeper. There's also the Open Alliance. I have a link here. It's theopenalliance.com. The Open Alliance is a set of teams who decided to kind of get together and post everything that they do in season and outside of season online. So they have their CAD public, their code public, they have build blogs live, they showcase literally everything. That team I talked about who was on Einstein with only a tank drive and a turret, they're an Open Alliance team, Team 6328. This team right here, Team 3847, Spectrum, they're an Open Alliance team. They're also fantastic. They were on Einstein 2019. They also have a lot of really great resources. So it's really cool that you can like take a look at this robot in the middle of season and say like, oh, hey, this works really well for them. Let me tweak our idea for our indexer or something. So those are different good ways online of figuring out if a certain concept is going to work. You also have previous robots of yours that you can reference, or previous robots in the world to reference, right? So you can go back to like, okay, this new game is like 2019, so I'm going to go watch videos from 2019. Or, hey, this climb is like the 2013 climb, so I'm going to, look at the 2013 climbs. Actually, a lot of teams did that in 2022 because the 2022 climb was very similar to the 2013 climb. So you can see a lot of, 254 concepts, or actually even for Spectrum, this robot climbed like Wyndham did in 2013. So, you can take a lot of inspiration from old robots. And finally, you have prototyping. And prototyping is where you take your ideas and then you figure out which ones you kind of want to test out in real life and test them out to learn information. And we'll talk about that in a second as well. So going back to the Everybot. So Everybot is from a team 118. They're from Texas. They spend the first week or so putting together a minimum competitive concept. And this includes bill of materials, CAD, code, everything. This robot is generally like, I think within the range of $1,000, and you can buy a lot of this stuff from suppliers as well as Home Depot. So it's super easy for teams to kind of make. And this is a really good starting point for teams who might not have as much experience or manufacturing ability, right? So in previous years, it's, a lot of teams found a lot of success with making a robot that was basically the every bot. That's exactly the every bot, or the every bot with like a slightly souped up climb, or an every bot with like, I don't know, you can modify it in any way you want. It's a really great resource, and I would recommend that most teams, keep an eye out on it and like keep track of it to make sure that they like can learn from it and see if like, hey, maybe we should be doing this. And you finally have prototyping, right? So if your online resources like the EveryBot or the Open Lines or Chief Delphi, right, you can't find the concepts that your students drew out, and you can't, learn from it there, I would look into prototyping. So you want to make prototypes that are repeatable, that tell you something about the game or game object, that provide critical dimensions that you can replicate in your design, and interact with the field in the meaningful way, right? So I have all those 4 things listed out because all too often you get teams who, and Code Orange is very much guilty of this, where you, you're like, okay, I want to prototype an intake, and you just take a roller and you just, put it over a ball and you roll a drill, and you just kind of like roll the ball at it, right? That's great, right? It's really good to get your students engaged and involved and be like, hey, I built this, and this is something that's super important to me. But what did you learn from that? Did it teach you something meaningful about the game? Did it teach you something meaningful about the object or how it interacted with the field? If not, then you're probably better off with making your first revision of your robot and learning from that, right? So you want to make sure that your prototypes are built in such a way that you can actually learn from them and figure out that something is good or bad. And I would say that high fidelity prototypes, right? So those are prototypes that you can kind of like roll on a carpet. I'll actually show some examples in a second, but like prototypes that are nominally like, pretty good are way better than no prototypes, right? I think that's pretty obvious. But I would say that no prototypes are actually better than bad prototypes and or low fidelity prototypes. And the reason from that, right, is with a bad prototype, you can learn the wrong lesson. With a bad prototype, with things that are super janky, you can say like, oh, this mechanism for sure will work, and then you make like a legit version of it, and you're like, oh my god, where did we go wrong? Like none of this works. Everything's bound up. Like I don't know what we did. Or it can go the opposite way, where you have a really bad prototype of a really good concept, and because it's just not like well put together, your team kind of throws it out the window, and then you get to the competition and you see 8 other teams doing that same idea, and you're super bummed out, right? So I would make sure that if you are prototyping, you make it useful. And a good example too is, attach it to old robots of yours that you might have laying around, so you can kind of drive your old robot around and have your robot, like if you have, a really simple intake, right? You can drive into the ball in the field and try to learn from field to field interactions. These are some examples of what I would consider some like higher fidelity prototypes. Higher fidelity doesn't mean they have to be like, super good or well put together in terms like they don't have to be finished products, right? So you can see here we have 2 students with drills and some wheels with some bearings and some wood. Yeah, you'll just see it. So this is from our 2020 season. Right. And what we're trying to learn here, right, is how do we serialize the balls? And this taught us a lot. It taught us that gravity feeders can work well. It taught us that like, oh, you can see a bunch of balls sticking in a row, but like having some sort of compliant force or like roller or something to help balls bypass another one is something that you probably want, right? So that's what we learned from that one. Another good example of a prototype is this intake. So the student built, I think they routed 2 pieces of wood and stuck a shaft between it and added like a motor from an old robot. And they just put it on a drive base and were able to drive onto pile balls. This prototype would be way better if we ran it on carpet, and I think we eventually did, but it did teach us that, okay, it's pretty easy to actually pick up balls, and they don't really stick together when you're intaking and like things like that, right? And it was able to help us figure out our dimensioning for the actual intake rollers on the real robot. This is like another example of a prototype that we did of like, full system integration. You can kind of see the intake with some brushes. This is actually not the best prototype. I think this is something that seemed cool at the time and I think was really cool for its students to kind of put everything together, but it didn't really teach us everything because we prototyped each of these individual things separately, right? But it was cool for us to see. A final example, right? It doesn't all have to be physical. So this is a prototype that a student did in CAD where they drew out, the CAD or some sketches for 2 different types of climbs. One would have 3 stages of climb and the other one would have 4 stages. And they just got these screenshots to show that a 3-stage climber would actually be good enough to reach the bar at the highest level compared to a 4-stage, because we're trying to figure out the design of the robot. So this is a really good way of also prototyping. You don't have to make something physical. You can just try to figure it out in CAD and make sure that the dimensioning works. So that's a really good tool to have in your tool belt as well. Finally, we get to step 6. So this is choose a concept. So now you have your goals, you have your specification list, and you have your ideas for your robot. And now you've gathered data on your ideas, right? On all your ideas. It's time to make a decision about your robot and your data. So at this step, I would also go back and revisit your wish preferred demand list and make modifications where necessary from learning about the game, right? You might learn that, oh, hey, doing the mid-level climb is actually way easier than we thought. Or, hey, shooting a ball from far is way harder than we thought. Things like that, right? So go back, modify your wish preferred demand list to, based off of what you learned. And then try to come up with an elegant solution that will satisfy your requirements. I would, generally recommend that you try to minimize your degrees of freedom. So degrees of freedom are moving parts on your robot. And again, build consensus here. Don't vote. Make sure that every student is heard. Students and everyone gets really attached to their ideas that they came up with. And voting here is also really bad because it can lead to a lot of hurt feelings and people stopping progress. So build consensus here. Make sure that everyone is heard and you come to the optimal robot that meets your team's goals and satisfies your wish preferred demand list with all the information that you've learned. This robot right here is, I think, another concept of our robot from 2016. And our 2016 robot basically ended up looking like this too, right? This was the result of what we learned from our prototyping and all that kind of stuff that year. All right, so those are steps 1 to 6. After steps 1 to 6, I would actually generally push that into post kickoff, right? Those are the nominal parts of building your robot, right? So that's, designing, doing the detailed design of the robot, fabricating parts, getting it together, wiring it, programming it, getting a lot of practice in, and, actually competing. And again, at every step of this, when you learn something, go back, revisit your wish preferred demand list, move things around, reprioritize things where they make sense. And make sure that you're continuously learning from the process. And that's super important to do post kickoff. Finally, I actually kind of have a sample schedule for season if teams aren't too familiar with aggressive schedules. So I would say days 1 to 3, or if you want 1 to 7 can be your kickoff. I kind of have the prototyping in days 4 to 7, right? So you can do prototypes and build a drive base, right? If you know that your team is going to use a kit parts drive, you can get it done from days 4 to 7. Or if your team knows you're going to do swerve, right? You can just, take your swerve modules, put it on whatever you decide your drive base is going to be, and just start making it on days 4 to 7. And start programming your drive base then, right? You can start trying to do simple autonomous routines. Day 8, I would lock in the design concept, right? So have the meeting where you revisit your wish preferred demand list and make sure that on that night, you know exactly what your robot's going to do and how your robot's going to do it. You don't need to know the detailed design, but know the general, okay, the robot's going to shoot like this, so it's going to have, this sort of mechanism, so on. Days 8 to 21, right? So those are week 2 and 3, finish the drive base and electronics, start programming the other mechanisms and building the other mechanisms. Week 4, right? So that's days 21, 28, that is finish putting together your robot and do more programming. And then from there on, practice, iterate your design, make new components if necessary, and add more software functionality. And fail fast here again, right? You want to fail fast there so you don't fail at competition, or you can learn from your failures at competition, right? So it's super important to be aggressive with the schedule early on. And I think that is it. Feel free to, my email is listed below. If you have any questions, feel free to contact me. But I think we're going to do some questions, I think.
Yeah, we have time for a couple questions. So
awesome.
First question is, Is there a strategy to balancing your robot's abilities with your other alliance partners during a match?
I guess there are a couple ways of like actually answering this, right? This is during kickoff and after, right? Or like actually at the event. I'll talk about kickoff specifically and, kind of tie it in later. But I think Code Orange's philosophy has always been be as flexible as possible. That way you can play with, the most amount of teams and, kind of create your own luck there. But again, this has to do with the resources that your team has available for you. So kind of just taking an example we can take an example from 2022 and 2016, right? So in 2016, the game was there were a lot of defenses that prevented you from going across the field and scoring, right? So you have to be able to cross these defenses. You also got a ranking point for crossing a certain amount of defenses. So super early on, most teams basically decided like, hey, we're going to make a low robot. And this was something that like a lot of teams did. You could see polls on Chief Delphi. You could talk to, your friends on different teams, and most teams were like, yeah, we're going to just do a low robot. And that afforded some few teams the calculus of saying, okay, I'm not going to make a low robot. I'm going to make a tall robot, a robot that is going to like be able to do maybe one or two defenses. And it's going to just be able to have an unblockable shot. And teams who were able to do that, right, they decided not to do everything. And we're able to take like a measured response of the community and base their decisions off of that, and had a lot of good success with that. In 2022, right, I think a good example of this is the climbs, where there are some teams who decided like, okay, we're only going to climb in the side, but have a climb in such a way that it would allow two other teams to climb up, right? So 254 and 2481 are good examples of this. Those were good bets for them because I think they probably saw that most other climbs could kind of climb anywhere. And they were also two teams who were good enough that they knew that they could choose alliance partners based off of this ability. So I think those are things to kind of keep in mind, right? Measure the community's response, right? See what other folks are doing, see what might make sense for other people, and based off of your resources, figure out what's good for you.
All right. Another question is, how many prototypes should you make before the final design?
My answer on this has shifted over time. I used to be a firm believer that you should prototype everything in a robot, but I'm actually not in that camp anymore. Some teams get away with not making any prototypes, right? So kind of going back to 2022, right? We had just come off a shooting game, and a lot of teams had success basically building like the same robot they built in 2020, but just a little bigger. There are things that you don't need to design, right? So if we have another lifting game, teams don't need a prototype. An elevator, right? It's something that you can look at COTS designs or look at previous robots. You might need a prototype like a grabber for your balls, right? Or you can look at one of the other open lines teams and their grabbers or something like that, and just use that. So this also depends on the resources that you have available for you. If your resources aren't really heavy, and or if your students aren't like really familiar with making things fast and good, I would, maybe skip the prototyping step and go straight to design and just make things faster. If you have a lot of students who have a lot of good experience with like wood tools and things like that, right? Make a couple of prototypes to de-risk some key things. But I think it's just whatever makes sense for your team.
Okay, great. Next question is, what is a good way to manage groups during a prototype stage?
That's a good question. Again, all my answers are this depends on team to team. I think you probably want to have a bit of structure. I think I've seen a lot of prototypes do well when there was a clear outcome of what you wanted to learn, and when you needed to be done with the prototype, right? So in what's a good example of this? I think in 2017, right, where you had gears, I think a really successful prototype a lot of teams had was something that would pick up gears from the ground. And from there, that's actually pretty simple in terms of the start and end point. You want your start to be a gears on the ground, and you want your robot to be able to pick up the gear and reorient it, right? Or to pick it up in general. And like once you had the robot pick it up, right, I think that's a really solid endpoint for that. But like for shooting games, for example, right, what's an endpoint for a shooter? I think most teams could probably throw together something that could like, had a flywheel on it and a hood and could like nominally shoot a ball, right? But you could keep on optimizing that as long as you want, or you could just like stop there and be like, hey, we can shoot, time to move on. Right. So I would make sure that your entire team or the group working on it knows what they need to learn to end the prototype. So whether that's like a rubric or, a scoring system, or like, you have 3 days to learn whatever you can from this concept. Right. I think having some sort of thing like that to guide the process is ideal.
Okay. Another question about prototyping. How do you prototype a more complicated design, such as a turret, in a timely manner?
I wouldn't prototype something like that. I would go straight to just design. If you haven't, for some teams, it might make sense to do like a really quick design that that you can design quickly and fabricate really quickly to give programmers some time to play with it, right? So like a turret might be a good example of that. But like for things that are like super complicated, it might just be easier to design it, do a couple of revisions in real life, because for those sorts of things, you need to like worry about your tolerances anyway, and your like different like orders of operations, right? But in general, most teams don't need a turret, so I think that's a different thing there.
Okay. Next question: is it better to put more time into your prototype/practice robot or your final robot?
If it's raw, I would say final robot. Yeah, final robot. I think that's if you had like the two options of your prototypes versus your final robot, I think final robot all the way. It's super important that you get your gains from there and you get as much practice time. Practice time, again, is like one of the most important things that teams skimp on. And I think like getting as much time and focus and effort there is probably the most important thing a team can do.
Okay. Next question: is there a time frame where you shouldn't be prototyping?
Do you mean this like early on in season or late on in season?
I think they mean kind of early on, like when should you stop doing prototypes and more like final design?
Some teams like have success basically prototyping the entire season through. But I think that's also hard to say. If you have a team that's large enough, you can have, a group of students prototyping something while students design the real thing as, the other students are prototyping. And the prototype information can feed into the CAD, but doesn't stop the CAD, right? So I think that's a good way of doing it. If not, I would say like you have, 4 days or 3 days to do your prototypes. And then from there, you're done. Or like, hey, we're not doing prototypes of all. We're just going to look at old concepts and just base a robot off of that and open lines. I think that's also super valid and can lead to a lot of success. There are like a lot of really good teams who don't prototype at all, right? I think like 2056 is an example. They don't prototype. Not really. I think there probably will be 1 or 2 examples, but like 2056 doesn't prototype. 179 doesn't prototype. There are a lot of teams that don't prototype. They just make their, the first iteration of the robot immediately.
All right. Well, thank you. That looks like that's all the questions we have. Thank you so much for that amazing presentation. Learning how to run a success. Yeah, no problem. This is obviously super important stuff since kickoff is coming up soon in January. And I think with that, we have reached the end of day 4 with our preseason panels. Thank you so much to everyone who tuned in for today and asked all their questions. Tomorrow is our final day for panels, so be sure to tune back in at 5 p.m. Tomorrow for our last panels of the season. All right. Bye, guys.